Hi! Today we're going to learn about applications of quadratic equations. Let's say we have a problem like this. The sides of a right triangle are x minus 1, x plus 2, and x plus 3. Find the perimeter. So before we get started, let's first draw this out. So we have a right triangle, like this. It's a right triangle, and we know that because the lengths of a shape are always positive, that this would become x minus 1 because it's the smallest side. This would become x plus 2 because it's the second smallest side, and this one would be x plus 3 because the hypotenuse is always the largest side. So, because we know this is a right angled triangle, we can find one of these sides in terms of x, or the other sides, using the Pythagorean Theorem. So we know that the hypotenuse squared, so x plus 3 squared, would be equal to the square of this leg plus the square of this leg. So a squared plus b squared equals c squared. So x minus 1 squared plus x plus 2 squared becomes x plus 3 squared. So let's multiply these together. X plus 3 squared would become x plus 3 times x plus 3, which would be x times x is x squared, plus 3x plus 3x is plus 6x plus 9, because 3 times 3 is 9. So x squared plus 6x plus 9 is equal to x minus 1 squared would be x times x is x squared, minus 1 times x is minus 1x, and then the other minus 1 times x would become minus 1x also, so that becomes minus 2x, and negative 1 times negative 1 is positive 1. Here we have x squared plus x squared plus 2x would become 4x, plus 2 times 2 is 4. So now let's combine like terms, and we get on this side x squared plus 6x plus 9, like it originally was. Here we get x squared plus x squared is 2x squared, minus 2x plus 4x is plus 2x, and 1 plus 4 is 5. So as we can see here, we have two polynomials, one on each side of the equation sign. So let's make this become one polynomial on one side of the equal sign. So we get equals 0 on one side. So as we can see, these terms are generally bigger, or at least the highest degree term is bigger on the right side. So we're going to subtract x squared, subtract 6x, and subtract 9 from this side to get rid of that and get 0. This would be equal to 0. And then on this side we're going to do the same, because whatever we do on this side, we have to do on the right side. So minus x squared minus 6x minus 9 becomes 2x squared minus x squared is x squared, 2x squared minus 6x is minus 4x, and 5 minus 9 is minus 4. So now we would have to try and solve for x. So as we can see, this is non-factorable. So now we have three ways of doing it. We could complete the square, we could use the quadratic formula, or we could graph it and find the roots. We're going to graph it and find the roots. So we have to graph x squared minus 4x minus 4. And let's let this load. And so now, to find the roots, we have to do second trace 0. So 1 root is x is equal to negative 8.28. So x could be equal to negative 8.28. Or sorry, negative 0.828. Negative 0.828. Another root, the other root, because this is a parabola that intersects the x-axis at 2 points, the other root would be 4.828. The other root would be 4.828. So now we have a dilemma. Which root do we use? So, remember how in the beginning we said that this is the shortest side because x minus 1 still has to be positive. Well, if each of the lengths of the sides has to be positive, then we know this is not an option because negative 0.828 minus 1 is negative 1.828, which cannot be the measure of the side. So that means that x is equal to 4.828. So now we have to find the perimeter of this triangle. The perimeter is x minus 1 plus x plus 3 plus x plus 2 plus, let's make some room, plus x plus 2. So when we type this into our calculator and substitute 4.828 in for x, we get 4.828 minus 1 plus 4.828 plus 3 plus 4.828 plus 2, we get 18.484. So approximately 18.5 units. So the answer to this problem is, this is equal to 18.5 after substituting this in for x. So the answer to this problem is 18.5 units. Today we learned about applications of quadratic equations.